Hello everyone, and thank you for coming today to our 7 and 8 ACC lecture. And so to tell our guests what is this lecture series, we will do a short introduction and then we'll give the floor to our guests. So the 2024 ACC lecture series is titled Limits of Architecture, Architecture of Limits. And it's a cycle of 12 seminars curated by a team of PhD students from the program of Architecture History and Project of the Politecnico di Torino. And this program is open to all the architecture students and aims to discuss among architects, researchers, designers, and other professionals related interdisciplinary fields. And our mission for this cycle is to transcend the conventional limits of architectural practice and architectural discourse. And we aim to delve in the concept of limit, transcending the physical relay into the virtual, social, disciplinary, technological, and philosophical aspects of architecture. And today we propose a double lecture that is titled Frontiers of Artificial Intelligence in Architecture, where we invited two of the main innovators in the field. One from the practice side, that is Fredy Fortich from MVRDV Studio, and the other one is Daniel Cardoso Llach, that is a professor at the Carnegie Mellon University. So we will start with the introduction of our first guest. So, very briefly, Fredy Fortich is an architect and engineer specializing in computational design, in coordination, performance-based design, generative design, and machine learning methods. He holds a master in building technology from TU Delft and a master of architecture from Universidad de los Andes in Bogota. He is a technical architect serving simultaneously as BIM manager at MVRDV French studio, as well as AI researcher on diffusion models for MVRDV NEXT. The lecture will delve into MVRDV as a data-driven design practice from its historical foundations to MVRDV NEXT current research on AI. Fortich will unfold the current applications of image-based MVRDV AI across the various design stages, so including brainstorming, reference research, conceptualization, collage design, massing, materialization, and rendering. Finally, the firm's current innovation in AI customization will be unveiled. So, that is it.
Okay, so as presented, I am a BIM expert, Fredy Fortich, BIM expert and technical architect, simultaneously working at the French studio and MVRDV NEXT. So this lecture is going to be formed of 5 parts. It's not going to delve too much into the how to do it, but rather what we can do with it, looking how to implement it. So the 5 parts are: first, MVRDV as a data-driven design practice. Next, what is AI in architecture? Third part is MVRDV AI applications. The fourth is the practical use. So what's next, what we envision, and finally the final thoughts. So MVRDV as a data-driven design practice. A little bit of history. The studio was founded in 1993 by Winnie Maas, Jacob van Rijs, and Nathalie de Vries. That's where the MVRDV letters come from. Our main offices are in Rotterdam, but we operate globally. We have satellite offices in Paris, Shanghai, Berlin, and the recently opened one in New York. So we have approximately 1,200 projects registered in 36 countries and the 6 continents. So now delving a little bit on the history, showing significant projects. This is the Dutch Expo Pavilion in Hanover. It was done for the 2000 World Fair. And it really, we really tried to show the innovation that we're looking at. We tried to promote. In this case, we are stacking Dutch landscapings one on top of the other. And this shows, these projects kind of, the idea is to showcase how we like to think outside the box. This is the Market Hall in Rotterdam, very close to our offices. And it combines mixing typology, so it's a shell, a housing shell, that envelopes a central area, and that creates a new public space, which is the market area in the center. It's 95,000 square meters, but the interesting thing, it was opened in 2014, and interestingly, Rotterdam was a city that had about 350,000 visitors per year, and it went to 4 million visitors because of the impact of the market hall. So we really believe the impact of what good architecture can do. Another project that I would like to talk about today is the Valley. So it's 3 residential towers in Amsterdam. So as you can see, it has a very complicated facade geometry. So that means that we had to develop very specific computational workflows. This was before Rhino inside Revit. So we had to really work with Revit to Dynamo to Rhino, and use Grasshopper to do some facade analysis and optimization, and then finally through Dynamo again to push it back into Revit. So as you can see, this image shows how every corner. Yeah. So this really shows how every corner and tile and edge had to be analyzed to classify and optimize as much as we can. So basically the basis of parametric optimization. This is a bit the workflow showing Rhino to Revit using Dynamo. So in the end, we need this information back again into Revit to generate the construction document. So that was an important step. And here you can see really the essence of what we were doing with the parametric workflows, or with the digitalization of this project, which is the facade kind of becomes a sort of folded notebook where each tile is represented by a letter. And you can really start to see and identify the shape by the data of the building itself. So here you can see basically that, but organized in the visual coding. Many of you might have been already using Grasshopper, so this is just to show that the workflow that went into to develop these classification workflow. And finally, this is a photograph of the final completed building that shows the extremely complicated geometry that had to be optimized again and classified. But it shows that had to be done to make it feasible. And I really believe that this wouldn't have been possible without a computational method or computational approach because of the complexity of this project. This is the interior of the valley, where we like to call it the grotto, because it's kind of referencing sort of canyon-inspired space. And I will go back later to this project, so how we like to look back at these projects. This is a snapshot of the projects in our offices, just to show that we not only work in architecture, but we also have various scales, like product design. We have done a lamp or a coffee table, all based on MVRDV design DNA. And we also do urban scale landscaping. But we also collect and publish research in the form of books, We like to collaborate with partners. This is a collaboration that we have ongoing still. It started with, it's called the Y Factory in TU Delft. And these type of collaborations, I think, allow us to look into the future and make a lot of radical make speculations of what cities would look like, the visionary cities of the future. So from academia, we like to also stay thinking and projecting what architecture should be like. So this shows a bit the speculations of data-driven design. So the heritage of MVRDV has always been data, the impact of information, like Metacity Data Town, which is a city that's described purely by information, or other instances where we explore how to organize a city through information or through data. So it's not a coincidence that MVRDV NEXT was born. It's our in-house research and development department. We like to experiment with AR, VR, CAD fabrication. But our main focus is parametric optimization or computational design. So this optimization, generative optimization, and finally, just recently, generative AI. Our methodology is a bit of a combination between the applied and the speculative, meaning we like to work with projects or do custom-based solutions for a specific team that wants to work with or develop a new tool. So we like to do that part, designing new tools, but also doing our own independent and academic research. So if architecture and urbanism of MVRDV looks something like this, our MVRDV NEXT looks more into the development, the transfer of knowledge, these digital workflows that can be used to enable new projects and new ways of thinking of architecture. This is another very interesting project where it's called the MVRDV Cloud, where we sorted the first 400 projects of the office by image. We can sort it by, all these images can be sorted by number, by date, even by color or saturation. But also, interestingly, we can choose the typology. So we have certain typologies that we tend to do in the office. One of these is, for example, the stack or the pixel or the valley. So all this is very useful when we have a very organized system of information, and it will be useful for AI. So I'm going to go back to this later because it shows how this data can be used. The current tools, these are the current tools that we have been using. Of course, you might be aware of them, or you are really aware of them every day. Rhino, Revit, Enscape, and Photoshop, all the Adobe suite. We are particularly interested in Grasshopper and Dynamo because it allows us to make our own workflows. They're customizable, modifiable. We can really add new functionalities to it. But of course, these tools are evolving and they're changing very quickly. But notice that these I also see as tools, or I call them tools. They're not AI overlords. They're not AI architects. They are tools. So maybe some of you have already used Midjourney or ChatGPT and Stable Diffusion. Of course, this is what everyone is talking about. But it's important to note, or I see that if you cannot use it, if you cannot do architecture the traditional way, then you shouldn't do it through AI. You need to have the base of architecture. So the second part delves more into what AI is in architecture and what this lecture is going to talk about. Specifically, so AI is a very broad term. Artificial intelligence encompasses many things. But the base of it's the simulation of human intelligence with a computer. And then deep learning is loosely based on the human brain. That's why it's called artificial neural network, because it's trying to copy the network of the brain. And finally, AGI is what everyone, all these companies like Meta and OpenAI are looking at right now, which is artificial general intelligence, which is an intelligence that's multi-purpose, that can solve many problems, not just architecture, not just math, but can really think like the human brain. Applications of AI, I'm going to show that. So basically, AI started through this discriminatory analysis. So trying to classify something like that, dog or cat or dog, by doing this classification through social media, through visual computer vision, we are now able to get to generative design. So this was necessary to get to chatbots, and this allows us chatbots or diffusion models, which is what we're using at Ethereum and recently Stable Diffusion. And this allows us to reinterpret and identify what we had seen. So we're going to delve particularly on what you see on the right of the screen, so generative creation. In this case, also, I'd like to point out that AI is not scripting. It's not the same thing. So even if you hear generative design is not generative AI. It sounds very similar, but it's very different. Generative design is scripting, so where the programmer sets up the rules, determines the relationships. So the example is Grasshopper. You can use optimization algorithms within this scripting framework. But on the other hand, generative AI is very different because it's probabilistic. So while one is deterministic, you define something, the other one is based on probability, and this is why it's called the black box, because the relationships are created by the AI itself. We don't really know how the connections are working. We just give it the input and then the output to generate the images. And finally, this presentation focuses more on the image based. So also on the right, there's the geometry based, where you can generate 3D models already. There are some tools online. Luma AI, Finch 3D, Plan Finder. There are a couple of these interesting tools, but for now, they're a bit dull and generate very generic 3D geometry. So my interest recently has been more on the image-based that are very creative. And in the end, images are the architecture involved is creating images. So this lecture will delve into the 2D, which is more on the journey than the unstable diffusion. So having this in mind, we focused on stable diffusion specifically because it's open source, so we can really work with it. One interesting way of how we design, or in general the design process, this is how it works. There are the stages of a project where you start with an idea, you have multiple ideas, and then you have to refine them. And as you go into the design development and construction documentation, you narrow it down. Well, what we are seeing is that we can really apply AI tools to each part of the design step. So it's this AI help. It's not doing it for you. It's just simply helping you get certain points. So I'm going to go into really quickly through all of these, and finally explain what we're doing with the AI customization. So first is AI brainstorming. So the idea generator, this is very simple. We can use ideas to generate images on the fly. So here's an example of Jacob and Natalie just testing out really quickly and finding what we could create. Comparing Midjourney with Stable Diffusion, Midjourney always has been generating much nicer, interesting ideas, but still, if we playfully asked it to do in the style MVRDV, and this is what it would do. So we were also trying to investigate what prejudice are already included in the model. Just some interesting ideas for projects, or just try to test out what we can do with the brainstorming. Next is the we like to call it super Pinterest or reference generator. So we can use AI to generate reference images and materials. We have a Midjourney corporate account where everyone is generating their own images. This is from the account. Everyone sees what what other people are doing, so we can really feed on ideas. We can see what other people are doing, and really it helps us to cultivate a bit the knowledge of what's happening around the office. Next is the conceptualizer or unifier. We can use AI to combine concepts to make unique solutions, or also a unifying concept. So what I mean with that is we use, for example, base pattern. This is also just doing Midjourney, but I see the interesting possibilities that you can use a base pattern as an image and then have a sort of overarching language for a project to make a sort of cohesive whole. That's more for the initial stages of design, but then you can also apply certain styles to an image. So up here we have the base geometry, very devoid of materials, with nothing. And then if we, for example, like the representation of a certain image, we can generate multiple thousands of options in a matter of minutes. So it's more inspirational purposes, just simply to restyle an image. But interestingly enough, you can also mimic styles that are already existing. So the graphic style by Fredy, we take an old project, revisit an old project from MVRDV, and apply this graphical style. It gives us very interesting results and have a sort of cohesive representation of a project. And then even also interior views works similarly pretty well to generate these cohesive language or graphical language. Next is collage design. So sometimes we ask ourselves, why should we even model? We use AI to test a lot of ideas, but sometimes you have to always go to Rhino and start modeling, or do it more specific. Here, what we do is we start with a workflow that's a very basic Rhino geometry. We take that, plug it into Stable Diffusion, and start to have a sort of conversation through Photoshop and AI creativity to get through the workflow. And you see it's going back and forth. So it's this sort of back and forth process. It's not a magical one that you'll get one perfect image the first round. It's more a sort of power tool that will allow you to test multiple iterations, refine your concept. So that's what I want to really make important. So it's not something that you're simply going to generate a nice image and it is what it is. It's more a tool that will allow you to refine your concept, maybe get ideas, maybe start refining it further, and it becomes a sort of conversational approach. Similarly, with the collage-based approach design that we're experimenting with, is to have this unifying language. So on the left is the original, just a very quick and dirty collage that was done without even modeling anything. These were just lines in Photoshop, and then use AI to recognize what's ground, what's gravel, and then make it into a more cohesive render. Of course, we've had lessons along the way. In this case, we've learned that we have to keep the level of detail very consistent. So if we have very little details, we have to let AI be a little bit more creative. So that's called denoising strength. We put a very high denoising strength that allows it to generate results a bit more more creatively. But if you have less details on an image, then you have to control that creativity. So in this case, we had a challenge of creating all these 16 collages in a very tight schedule. So a landscaping project, and this was the result. So we were able to kind of have this unifying same style of these 16 images in only 4 days. And similarly with this project, what we found very interesting is that we can use AI to draw and see what we want to see. So someone from MVRDV traveled to this project site, and through drone and aerial photography, made a digital survey of the project, of the site, through photogrammetry, and that allowed us to have a point cloud data of the whole site. So usually when you go to a site, you take a lot of pictures, but most of the time you take a picture and then you missed the perfect angle that you wanted to be in. So the interesting thing of having this digital model or digital twin is that you can visit it from any angle, again, virtually, find the perfect angle. This is where we want to build, for example, a bridge on the site. And we start really intuitively starting to paint with PowerPoint or any paint software what the architectural intention would be. So we want some flowers here, we want to make a bridge that's connected, and then start to refine it the first round with high creativity, just to generate a little bit more of a cohesive image. And then the next one with a little bit less strength, just to start to refine a bit the information, the architectural proposal that we have. But then you can generate thousands of images in a matter of seconds, and it generates also images that are weird bloopers, like the one on the left. So it makes a whole cartoon character instead of a bridge. So there will be bloopers, and that's why it's important to say that you need a pilot, a human pilot, to filter out, to become a sort of curator of ideas and choose amongst all the options that you get. Really quickly, I'm going to go through massing, batch iterations, which we can use AI to explore just as you saw before. You can get so many images that you can simply explore a lot of massing and color options. So this project down here, you see the text prompt that was used. And in this case, we just wanted to try really quickly some material options. We wanted to do maybe a gradient, but trying to model that gradient is very complicated and very time consuming. So this allowed us to really quickly brainstorm color combinations, maybe get inspiration for color combinations, and all by using the weight of the word. So here, what you see after the word is the weight that we give to each word. So the more important the AI should use these words to generate the image. Similarly, we can use it for interior design or materialization. You've probably seen it throughout social media, where you can start with a clean landscape render and use. Here we decide to use the different landscape channels, like the edges, the material ID, the object ID, to run it through different AI preprocessors that are called Carnegie. They have specific names, but basically the idea is to freeze the geometry and test with the prompts that I mentioned. So you really start to give a little bit more weight to what you want to see. For example, brick facade. In this case, if you see the timber interior has a 1.4, you can go from 0 to 2 is the image weight that the word weight that you can get it. The higher you go, the more it will generate this generate the material that you specify it. So in this case, maybe trying to timber interiors, going a little bit crazy and trying to do a neon interior. This was more as a fun exercise to get something, some naivety back into the design, maybe something bioreceptive, a little even something playful like Venice. This is of course just for fun, but it also helps us to see what the prejudices are in the model. Because if we say, for example, elegant is this is what it considers elegant. But maybe we go a little bit crazy and start to inflate it to avoid injuries on children, and then we get to something like this. Or go completely crazy and make it 100% child-proof lobby to test. But this again is just a fun joke, but it's more to test the limits of what you can generate. So to test how closely we can generate our intentions into the geometry that we have. And finally, AI rendering, which we can use it to, we say hallucinate materials into a blank video. So in this case, this is to the left is the wireframe input exported from Revit. And then this is one of the options that it generates, so it keeps a sort of consistency. And as you can see, as you go into the space, and it loses the geometry, it starts to hallucinate certain geometry. While it has the geometry, it'll keep it very close to our intentions, but as you can see, it starts to hallucinate certain information. So this is some ongoing research that we're doing to try to keep a consistent image, because usually one of the limitations is that the images are always, even if you plug in another image, it's going to generate a different result. And of course, we can use it to change the character of an image. So this was the original production render that we thought it was a nice space, but it looked too dark and moody. So then use Stable Diffusion AI to make it a little bit more light and inviting. Likewise, we can also upscale existing images, so make a very low quality image into a high scale image. You probably see it in other website tools. For example, this is a Midjourney image that we really liked, and this is the zoom version of that image. So just to compare, the original is on the top left, and it really starts to recognize certain elements of the image. So it recognizes that this is a car, and it starts to add reflectivity, or it recognizes that this is an element of the lighting, so it turns on the lights of the cars, or it adds reflective elements to it. And next is what we see, what's next, and we contemplate that for now we need to customize it and really give it our own design ethos. So we take again the same stages of design, but this time we use our own customized tools and customized workflows. So custom upscaling, just as I showed you before that you can upscale an image, we are working with a graphic user interface called Comfy UI. So it's similar to Grasshopper, but in this case it's for Stable Diffusion. Stable Diffusion is basically the engine, and this is the user interface. So we're interested in this one because it's a node-based visual programming tool that allows us to really develop our own custom workflows and really tap into the power of upscaling in this case. Here we upscaled it a couple times, 1, 2, even 3 times upscaling to take, for example, this original image that was of a bakery in Stable Diffusion. We take this image and then it upscales it, so it looks very similar to the original image from this perspective. But this is to the that up there you see the original size of the image, and this is the new upscaled version. It does take a lot longer to upscale, but then the interesting thing is how if we zoom into, for example, a particular part of if we zoom into this part of the image, we can see how the upscaling method really improves quite a bit. So we really start to question how much rendering time do we need, or if we can simply upscale existing images. So again, the original image, the upscaled version, all this with our custom workflow. And of course, this had to be, the idea was to make this a bakery, so it makes some delicious looking bread. Also, live AI, we're delving into a little bit of this custom workflow where we can test different options and start playing a bit with a webcam. So this is a little proof of concept where this is the webcam view. This is what the AI is understanding from the webcam view, and then seeing what else it can generate. So in this case, I just made myself into Van Gogh just to see what you can generate. So of course this has some sort of latency because you need a powerful computer, and it depends also on the creativity you ask for it, but it works interestingly well if you have a little bit of time to generate these. And of course, this was the proof of concept. This is a bit the workflow, how it looks with all the AI views, the webcam view, and then running in Comfy UI to generate finally this part is a little bit of upscaling, and then finally to generate the AI render. And this shows the intuitive way. In this case, it's actually using architectural models. Here it's changing quite a bit the geometries because we had a very high denoising strength, so creativity strength. So it's really changing quite a bit the character of the image. So then we try to make it so that it really keeps a bit the model here. Down here, it's very small, but here you see the original model. So here in this case, it's really keeping the geometry, but adding windows, or when we have something that has a lot of texture to it, it makes the texture into vegetation because we put texture and vegetation here. We put like a white cube on top of it, and it starts to try to close it off as a facade element. Of course, we do, this looks very low quality because it requires high computing power. So as computers become better, it will probably become better also. But the interesting thing here is that it allows you to really become a little bit like a child. It's very intuitive. And I like to think of it as going back to our roots of when we were designing or playing with Legos. So this, of course, it's a little bit like rehumanizing the computational workflow because it allows us to really play with architecture, with models, and get these results. So these are these two are the views that the computer sees, and this is the final upscale result. Of course, I have to mention that this is out of research and curiosity. This is it's simply new ways of interacting with physical models of creating architecture. It's definitely not how we design buildings. So just to be clear, it's a research project. Maybe it could be in the future a sort of conversational approach of how to design buildings. It's not what we do, but it just opens up new possibilities, basically. And we like to play with that. Next is custom LoRa's. This should say mini models. So yeah, mini models. So we train custom LoRa's or AI to learn what is MVRDV design. LoRa's are basically, so if Stable Diffusion is this huge model that was trained on 5 billion images scraped throughout the web, a LoRa, which stands for Low Rank Adaptation, is basically trained our own custom images, so just the MVRDV images, so that we can teach it to learn, in a way, learn a new concept with our own descriptions. So here we trained it to, if this is the MVRDV co-living catalog, axonometrics, we learn it a new concept of axonometric, and then it can, because it already knows how to do kitchen, it does an axonometric kitchen. So you see, based on the co-living, so this is the original image. Oh, this is a bit cut, but this says original training data, and this is the generated thing, the generated image. So it's really try to control the AI. And again, I mentioned the valley, so we like to look at our previous projects, revisit our projects, and use AI to reinterpret and learn from them. So this is how we would go about into training so we call it the Valley LoRa, where we use AI to caption images, and we do a pair of images and their description. So here you see that image, and there's a bit of description of that image. We go through and start to refine that description. It's called reinforced learning through human feedback, and that's the magic of training, where we really write down what we want to teach the new model, and then we feed it back into the Stable Diffusion training mechanism. And then this is the original image that I showed you before of the grotto. So it learns how to generate this grotto, and then use the base image and apply the LoRa to apply a similar materiality and stone facade of the valley. But not only can we generate the materiality, but also this says no LoRa, and this is with LoRa. So with no LoRa, it's a very generic building, very beautiful, but generic, I feel. And when we add the LoRa valley, it generates a building that looks a little bit more like the valley. So it's a bit going for full circle, where we started with a computational design digital workflow, then made it into reality, and then take that reality, take those pictures and plug it back into the computational workflow using AI. So again, learning from ourselves. So now we're looking into collecting all this data. So that's why I mentioned the MVRDV cloud. All this data comes very handy, because we can really start to organize and teach it by photos, or take collages, take diagrams, and make our own MVRDV Valley LoRa, or collage LoRa, or Axo LoRa. There's many more that we wish to do. In this case, I'm going to look at the collage one. Similar approach. We take all these collages that were done by a great artist in the office. This is a bit the original collage, which is very beautiful, and we really like to replicate something similar. Of course, this is much more defined, but as we train the Valley LoRa, once the LoRa is trained, as we start to give it a bit more strength, it starts to make the image. It progressively makes it a bit more as a collage. So this is the original one with a very low strength of LoRa. And then as the LoRa strength is increased, the image acquires a more collagey look. But of course, you can go overboard. This is what we call overfitting, where it makes this sort of burnt out, messy, garbled effect. So it's also playing with the amount of strength and the amount of training that goes into these models. So we generate various LoRa's, different epochs or different generations of LoRa's, and then we test all these generations of LoRa's and see, okay, this one is the best that generates collages, and we take that one, and that's the one that everyone in the office starts using. And again, looking at images from the past, the Expert Pavilion, we use AI to reimagine it as with a collage LoRa. Interestingly, also we can mix LoRa. So in this case, this was a quick study on how to make the Valley LoRa plus the collage LoRa. So this is just Valley LoRa, and then this is Valley plus collage LoRa. So it makes also kind of a collage Valley. And finally, final thoughts. There is, it's not a perfect system, of course. There's a lot of shortcomings. There's shortcoming in repeatability, consistency, and coherence. So as I mentioned before, if you generate one image from this angle, they generate the same project from a different angle. There's that limitation. Even though you use the same seed or the same noise at the beginning, it will still generate somewhat different, not coherent results. So that's why we're investigating the video or photogrammetry methods. There is also, of course, the issue of constructability and sustainability. Now you can get very beautiful, nice images. Anyone can generate images, but you have to be a critical thinker and say, does this even make sense? Should we even present this to a client? So the thinking behind it is what's valuable, not just beautiful images for the sake of being beautiful. And then, of course, the copyright. We try to, with the copyright, we always train our own LoRa's with our own proprietary images. So all the only data sets are images of MVRDV. And then just to end it with this, two interesting articles, one by Oliver Wainwright. It says, will it wipe out architects? The spoiler is no. There has always been these reflections that will this technology replace the other and make it obsolete? There is, of course, a common hype curve, but I think humans are very good at creative thinking and even inventing problems that we need to solve. So it's like it's the human spirit to always come up with something else to solve. And there is all this speculation. When CAD came out, everyone was thinking CAD was going to replace architects or parametric design or generative design tools, BIM. All of these are tools and they have their place, they have their use, and all of them have limitations. Similarly, AI everyone is on the hype curve right now, but of course it has this place and limitations. So this is a bit the hype curve that he mentions in the article that we thought it was very interesting. So when a new technology comes out, it's this wow effect and everyone is thinking that it's going to change everything, and there's these inflated expectations. Then we fall into the death valley of hype where, it doesn't really work for anything. But in the end, if we take the slope, the longest learning curve slope, we get to this plateau of productivity. You do get better results, but not as drastic or as altering to the architectural discipline as what we initially thought from the hype curve. And finally, the intelligent superabundance is a very interesting article that says if you build a highway, the highway will be filled up with more cars. In this case, this is the concept of induced demand. So if you have more intelligence, people will demand more intelligence, and probably maybe we're going to have clients that are going to expect higher expectations. So in conclusion, generative AI is a very useful tool, not AI architect, and it will become more and more useful as the technology develops already with many interesting developments in the field of AI, but we must learn to tame it. We must learn how to direct it. And basically this metaphor shows what we have in the current AI, which is a flashy, clunky, wasteful monster truck, and what we really need is something more trustworthy, simple, efficient, well-designed, like the Fiat truck. Thank you. And then, yeah, if you would like to follow more, you can look at my Instagram account where I'd like to do these current explorations. And yes, that's it. I urge you to go and play with it.
Thank you very much for your presentation. If you all agree, we move to the second presentation, and then for all the questions, we will have all the questions at the end. And so we will leave the floor to Professor Cardoso in the meantime that he prepares for his presentation. Yes.
Okay,
yes. So I just wanted to ask you if there are still some spaces between the lines. If we can stay closer and make space for some other people so that they can sit down and not have to stand up all the time.
I think so, yes.
Yes. We should be able to share the screen. Once you prepare for the presentation, I will give you a short introduction. So, Professor Daniel Cardoso Llach is Associate Professor of Architecture at Carnegie Mellon University, where he chairs the graduate program in computational design and directs Gardella, a research and learning laboratory rethinking the role of computation in the design and production of the built environment. He is the author of publications, exhibitions, and technologies critically exploring the nexus of design and computation, including the book Builders of the Vision, Software and the Imagination of Design, a history of computer-aided design that identifies and documents technological theories of design emerging from post-war government-funded research projects at MIT, and reflects critically on their architectural repercussions. His new book, Designing the Computational Image, Imaging in Computational Design, co-edited with Teodora Bardoli, draws from historical and contemporary materials to trace the emergence of computational design ideas and practices across a broader landscape of institutions in the US, UK, and Canada. In this talk, Professor Cardoso Llach will explore the long history of generative design methods and consider some critical issues concerning the recent adoption of machine learning techniques in architectural contexts. Finally, he will sketch out some new directions for employing this in design, architecture, and construction, drawing from recent research at Carnegie Mellon Computational Design Laboratory. So I leave the floor to Professor Cardoso.
Can people hear me? Hello? Yeah. Thank you so much for that very generous introduction and for the invitation. It's super nice to be here. And thank you, Fredy, for an amazing presentation. So I'll try to tell you a little bit about how we are thinking about AI in the context of architecture and design. The orientation of my presentation will be more kind of focused on sort of trying to provide a general kind of historical context for the evolution of these techniques. As Federica pointed out, try to raise some critical elements for the conversation and then show some recent projects that we've been working on the research side and the speculative side of things. I want to start by saying that something that makes discussions about AI in architecture difficult is the fact that AI is not a very precise term. It's a term that encompasses like a large amount of a variety of technical tools and ideas and concepts. And that ends up giving AI, and I love the posters for these lectures because they're like doing this, they give AI a sort of overarching, kind of almost ominous presence across everything. And I think Fredy also kind of hinted at this in his presentation. It feels like something bigger than ourselves and bigger than our society. And I think it's really important that we rethink that and we learn to see AI as a much more contingent set of tools and resources and ideas that have particular, that codify particular worldviews and interests and so on. So this is a little bit of an outline of what we'll be talking about. I'll first give a sort of quick, short overview of the prehistory of generative, what I see as the prehistory of generative design, drawing from traditions in architecture, but also in art and in music. Then we'll look at the development of some of the contemporary techniques for AI and some critical elements, and as I mentioned, a few new directions and a discussion. The recent projects are work developed at my with my group at CMU. So despite, is this not changing? Yeah. So because something that is important for me to emphasize here is that despite the aura of novelty that artificial intelligence has in our contemporary discourse, these ideas have been around for a long time. Ideas about automated machines, supporting creativity, making design, music, architecture, building automatically at the press of a button, they have been around for a while. And I think that's really interesting, and that's kind of the perspective that I want to start with. Take, for example, the work of Frederick Brooks in the 1950s. Brooks and his collaborators at the Harvard Computing Laboratory developed a method for generating musical sequences or musical pieces by numerically encoding a bunch of musical pieces. So what we see here on this side of the screen is really like a probability table. Basically, a table that codifies the probability of a musical sequence of a note to follow another note in that small data set of musical elements. And then from that set of examples, Brooks and his collaborators were able to develop basically a system that was using randomness and stochastic processes to generate a new musical piece that wasn't like any of the previous pieces, but that fit within the stylistic space of that data set. And I mentioned this little project. It's a little far from architecture, but I think it captures some of the sort of inductive reasoning that underlies what we use today as generative design tools in design, in image production, and so on. The idea that we can take a set of examples, so we can analyze them using statistical techniques, and then producing something that fits within that statistical landscape. Another early example of also computer music, also part of a university research laboratory, is the work of Ledger and Hiller in the University of Illinois. And he's kind of famous. Some of you are kind of attracted to the world of new media and computer music. Hiller developed something called the Iliac suite. the ELIAC was the big mainframe computer that they had at the University of Illinois. Interestingly, Hitler was not a musician, he was not a designer, he was not a computer designer, he was a chemist. And he was interested in the structure of molecular bonds. And he was experimenting with how to translate those molecular structures into other forms. And the process that he developed and the program that he wrote basically translated that geometric structure of molecular bonds into a stochastic system that produced musical sequences again. In this case, it was not a frequency table like the previous example. He looked at Palestrina, the Renaissance Italian composer, and he abstracted a series of stylistic rules from his work, and he used his program to sort of check stochastic results against those rules. So the computer would produce something random, and then it would check that random occurrence against the rules of the music, and then if it was positive, if there was a match, it would become encoded. So this is a little different. It's a rule-based kind of approach, but it's also harnessing this kind of stochastic generative possibilities of the computer to produce many things and to check those things against a stylistic template and so on. How did these ideas start to come into the world of visual production, art production, and design? At the same time, we have some fascinating early examples of computer art. What we're seeing on the screen is the work of Vera Molnar on the right and Federica on the left, famous pioneers of computer art, which they're different from the previous examples. They're not codifying sequences of numbers as musical elements. They are playing in the two-dimensional canvas of the computer screen. Well, not even a screen, because they were working with pen plotters. But they were working on an XY world. But they were using similar ideas about random generation and about checking that random generation against particular constraints and parameters. In this case, the constraints and parameters were playful in some cases. In this case, there's a reference to Paul Klee. In fact, that's called a tribute to Paul Klee, which expresses Federica's interest in stylistic capture or like an early form of style transfer, codifying rules that represented a sort of artistic and visual practice, and having the computer more autonomously generate objects that fit within that with that description. Architectural researchers soon started to be interested in this world of early computer generation, computer art, and some of the key examples, early examples of generative art have to do with a theory and praxis called shape grammars, developed by mathematicians George Steiny and James Gibbs. So basically, they were interested in thinking of visual elements as computable. So they were not so interested in codifying things numerically, like Molnar or Brooks or Hiller. They were interested in seeing visual information as computable entities and to define visual rules that allow you to compute with visual information. So it's a little bit of a different take, but I would say it's also within the space of this kind of general cultural transformation of post-war science in the US and Europe that brought ideas from information theory and cybernetics and new mathematics into the worlds of visual design and production and artistic production. So one of the kind of earliest examples that of this approach to generative architectural representation is something called the Palladian grammar, which, as you may guess, it's an attempt to codify the stylistic sort of signature of Andrea Palladio's architecture in a discrete set of shape grammar rules. So Steiny and William Mitchell worked together on this project, and they basically analyzed everything that was to analyze, everything that was published about Palladian architecture, and visited a bunch of buildings, and they came up with this kind of, I think it's 99 specific rules. And by rules, I mean transformation rules, like from A to B. Like you start from here, and then you end with this. And they argued in a paper that became viral in 1976 that set of rules captured the entirety of Palladian architecture. And they tried to prove that by generating a bunch of Palladian villas with the grammar, and then ask a set of Palladian scholars, and they mixed like real Palladian buildings with some of the generated buildings, and they showed that they were not able to distinguish them. So that's kind of a nice early 1970s version of generative design using shape grammar rules in this case. And I think I'm interested in that parallel between the idea of inductive reasoning, right? Which is, again, a consistent pattern between these early examples of computer art and computer design and architecture and contemporary uses of machine learning. So this is kind of a style transfer or style capture idea. At the same time, we have another vector of development, another vector of technical and conceptual work connected to the development of some of the earliest computer-aided design tools, right? The previous examples that I showed were experimental and conceptual. They were meant to kind of like be playful with the computer and try to kind of simulate creative practices with the computer. In this case, we have an attempt to sort of harness the very real capacities of the computer and to put them in the service of design problems, design questions, and so on. And as you can see in that funny headline there was already this idea that the computer was sort of a surrogate human, right? The idea that the computer is like a person, right? That's new. I think it's interesting, and I think we all belong to a generation, different generations, but we all belong to generations that grew up with that idea already as part of the collective consciousness. But that's relatively recent. Up until the 60s or like late 50s, there was no sense that the computer was this human-like presence in our culture and society. So this is an interesting moment. This post-war moment is key. We're still living in that moment. In this case, the researchers behind these projects, they were imagining that the computer would take care of the drudgery of physical labor, take care of the toil of calculative tasks, and they started to imagine a separation of roles between human and machine. And the human was given the agency of being creative and intuitive, and the computer was given the agency of doing these more mechanical tasks. At the same time, researchers in these kind of large institutions started to experiment with alternative configurations of human and machine agency. So some people, like for example, Nicolas Negroponte, who was an architect who went into the world of computation and computer-aided design, started to use software in the 60s as a way to experiment with new ways of imagining design and architecture and urban planning. What we see on the screen is a reconstruction on that side of a software that he developed in 1967 called Urban 5, which was like a sort of generative, perhaps one of the earliest generative urban design systems. Basically, you could type commands, or not commands, you could speak to the system in English, and you could tell it to say, oh, I need a building that of this area, and no higher than this. And I need to have this number of accesses, and I need the views to look in that direction or that other direction. And the system would generate an option. And if the system was over-constrained, the system would say, oh, no, sorry, there's too many constraints, you have to go back and rethink this. So it was an early attempt to use natural language as a way to interact in a more conversational way with a computer in a context of design and architecture. Interestingly, by Negroponte's own admission, the system, and I use his words, inexhaustibly printed garbage. So it was a little bit like a ChatGPT of architecture. And I think that's an important thing to keep in mind. These systems were experimental, were meant to kind of advance a vision, to speculate with a possibility. Their implementation was never perfect. For example, this other example is called CIS, which means computer implemented site planning. It's also like an urban, like a site design application that was theorized by Cardoso Llach at CMU in the 70s. And it's a system that allowed users to kind of design a unit and define a path for those units to be populated. And the system will go through a simple heuristic, we'll call it a generative process, to kind of allocate those units in a way that respected some constraints. So again, we have this idea of introducing constraints into a system and having the computer sort of do the generative work of producing many options, and then checking those options against those constraints. In computational design terms, we often say that as we often describe that as a design space. There's a design space that is sketched out or defined by a set of parameters or constraints, and the computer generates things that are within the boundaries of that space. So this is, I think, these two examples are interesting to me because, to me, they very clearly are storytelling devices. They are early examples of using software and the computer as a way to rethink how architectural and site planning and urban design should happen. They are theoretical artifacts in some way. They are advancing a theoretical idea about what design should be or could be in a new world shaped by the possibilities of the computer. At the same time, on a more critical note, for that same reason, it is sometimes difficult to connect these specific systems to the problems that they were meant to solve. We'll get back to that in a moment. So this is kind of the end of the first part. So a few things as takeaways. There was a new context of post-war science, combining vectors from information theory, from linguistics and cybernetics that start to enter the world of design and architecture and artistic practices. This is a traceable phenomenon happening often around institutions like universities and industry laboratories, because in those places there were computers, and these were large machines, and it was expensive, etc. And they generated kind of the seeds of what we understand to be today as generative. There's an idea of open-endedness within stylistic and functional constraints, and the idea of a design space that I just mentioned. And again, we have the emergence of new understandings of design that are no longer just human, but also design starts to become like a human machine endeavor. So, just in this part, I'll very briefly kind of suggest a few elements for the origin of today's machine learning techniques that are rooted in some of these inductive reasoning ideas, these ideas about statistical analysis and probability and so on, but that are infused with new energy through the kind of implementation of neural networks, as Fredy mentioned earlier in his lecture. That's one of the key technologies behind what we call AI, and they are based on a computational interpretation of neural networks, of actual biological neural networks. This is an image from an important paper from 1958 by psychologist Van Rosenblatt, who's kind of the person who formulates this idea of a neural network and becomes extremely popular. I show this not because I want us to stay rooted in history, but because I think it's important to remember that these technologies are not new. These technologies have been around since the 1950s. What has changed over the last 15 years or so is that we have access to more computing power, we have access to large data sets that have sort of infused new life into the promises of these statistically kind of oriented researchers from the 50s and 60s. Some of the first applications of this technology were in the 90s to read checks, to read kind of the writing of checks and so on. But of course, this is the technology that underlies a lot of what we see in generative design. Google image search is based on this technology as well. And of course, they are the foundational technology of deep learning networks. In architecture, there's a lot of interesting explorations. I don't want to go too much detail. We just had like a wonderful overview of rooted in practice of the use of these technologies. But I'll say that, that there's of course, a lot of interesting possibilities, exploratory possibilities in harnessing large data sets and mobilizing those data sets in order to style images, to kind of generate new insights from those images as a sort of serendipity machine, or to find similarities across multiple bitmaps and so on. And it seems clear from the work that we've seen today and also from the broader space in architecture that many architectural practices are going to change or are already changing as a result of these technologies. One of my colleagues, Kyle Steinfeld, who works at Berkeley, has produced images that I think are incredibly disturbing and interesting and profoundly evocative. And I like something that he says about AI. He says that AI can be a material, an agent, or a provocateur in architecture. And I think he uses those three frames to think about the different ways in which architectural practitioners and architectural researchers may think of AI playing different roles in the process. I think Fredy's lecture also addressed some of those approaches. A challenge of this approach that is based on images, I think, I'm moving to the next stage where I will try to kind of outline what I think are some critical elements for conversation, some things that I feel we should keep in mind when we think from architecture about artificial intelligence, and is the notion that a lot of what we see in AI in architecture is very much pixel-based. It's about image production. And that is great because a lot of architecture is about image production. At the same time, I think it's also important to recognize that there is a rift or a distinction between the kind of things that we can do with a pixel-based kind of result and information that is semantically rich or three-dimensional and so on. And I see some of the interesting work that I see happening today is trying to kind of explore the connections between these two worlds. The work of companies like Hyper and Finch 3D point to applications of AI that are trying to bridge that gap and apply AI technologies in ways that support specific layout generation, space planning purposes, and so on. Another critical element, in my view and that of others, is ethical. What does it mean for creative practitioners, including architects, that their work is being sort of drawn from the internet and then sort of reproduced in altered forms? Is this a form of sort of intensified or automated plagiarism, or is it simply transformative use? Some people say it's not plagiarism because it's transformative. Can a future of AI be imagined where these systems cite their sources or even compensate them? How to think of this as part of the creative community as architects? I think it's important to reflect on that. I thought it was really interesting in Fredy's presentation when he mentioned that they were training their models based on proprietary work from MVRDV. I think that's a really interesting way of thinking about it. It's like, yeah, we're using AI tools, but we're being very careful about what we're using, what we're feeding into our models. I think that's a very, very interesting approach to the question. There's another angle, another critical angle that I think is important to keep in mind, is the question of labor. We are expected to believe that AI technologies happens magically or autonomously. In reality, AI technologies, especially image-based AI technologies, rely on the invisible labor of thousands and thousands of people who are clicking, labeling in the clickwork industry, often in India, Pakistan, and so on, people who live very precarious lives. So on the one hand, I think it's important to recognize that these tools are not ephemeral, they're grounded on very material, very labor-intensive practices of labeling and codifying and curating these data sets. And at the same time, I think it's important to recognize those labors and how they may change the way we think about technology. A third critical challenge, I think, is environmental. We should be thinking about that. I think events in this great kind of conference and Biennale are also asking questions like this, and it's important. We cannot separate these things. AI is not very sustainable as we do, and the endless need for processing power and servers and data banks and data centers around the world, and cooling those data centers is really imperiling our ability to decarbonize. It's real. It's actual. Yeah, it's a complicated problem, and but I think we should keep thinking about these problems because they're not easy to solve, but we shouldn't ignore them. So it's worth asking who's really benefiting and what is this for, and is it worth it? A related critical element has to do with the fact that generative systems for the automated generation of military targets are being used today, in fact now as we speak, to carry out policies of mass displacement, land dispossession, and indiscriminate acts of urban, environmental, and human destruction. So there's a big irony there. These systems also play a role in those acts of violence, indiscriminate, massive violence. I find it ironic that despite the idea of AI as being sort of alive and human-like, at the same time, AI can be used to create a world emptied of life. There are no easy answers to these questions. These are difficult things to think about, but I think it's important for our architectural sort of culture and scholarship to keep them in mind as we engage with these techniques, because when we do so, we are also engaging with a worldview and with a new set of relations. And as Donna Haraway asks, we should stay with the trouble. We shouldn't ignore the trouble. We should keep it in our minds. As we engage, as we think creatively, we should also keep these difficult questions in mind. So returning to our question about, architectural research, I think it's important to recognize that, yes, architectural practice is changing, will change. It's always changed, and that's good. My optimistic view is that the profusion of AI image generating technologies will engender very kind of new kinds of craft practices involving the curation of data sets, the development of new workflows that allow us to kind of think critically about these technologies in architecture, and also to kind of move away from facile utopianism and now realize that the Biennale's title is realist utopias, right? So more kind of ideas that are more grounded on the real. So just to finalize, I wanted to show a few kind of quick examples of things that do not solve those difficult problems that I was mentioning, that show examples of how we are thinking of them and how we're trying to kind of implement these technologies in our lab in the process of finding new analytical and new generative potentials. I summarize those in 3 conceptual moves that I think are important. One is to think of data as a kind of material with which to design. Second, the concept of hybridity. Hybridity in terms of disciplinary and methodological hybridity, being kind of open and curious and able to ask questions from outside our disciplinary lens and engaging other ways of thinking. And finally, the idea of the interface, broadly understood to encompass the kinds of encounters that we want to see between humans and machines. So so these are kind of the 3 elements, and I want us to think for a second about data, right? Data, the concept of data, the object of data, which, as you've seen in, I think, in both presentations, it's kind of the fuel, the substrate of all of these techniques. And I want us to think of how data is often presented as a natural resource, something to be mined, something that is there and it's inherently kind of valuable, inherently truthful, inherently objective. And I want us to think a little differently about data and think about it as something that we are actually building and making as a sort of design material. I'll illustrate this with a couple of projects of what I call architectural distant readings. So we're really interested in the potential of machine learning methods to help us see architecture in different ways. And researchers and scholars in the field of the digital humanities have come up with this interesting concept of distant reading. The idea that instead of using the traditional tools of the scholar, which is to look very carefully at one object, computational methods and machine learning and text mining and network analysis may help us look at things from a distance. So instead of looking at a particular building, or in the case of digital humanities, a particular novel or a particular author, we're looking at an entire genre of work, or 2 centuries of literary production in France, or the entire corpus of film in a particular, by a particular group of authors. So what kinds of insights can we derive from architectural distant readings? And that's the question that I'm interested in with these projects. We've done work to create data, to sort of laboriously find new data structures to describe architecture, not new, but to implement data structures that codify particular traits of architectural space. In this project, we were interested in the spatial configuration of a wide range of temples from different faiths. We wanted to understand if there were sort of patterns or if we could cluster this type of architecture in a way that allowed us to see how it clustered around questions of spatial structure and so on. We developed a graph-based representation that codified the depth of the space, and that allowed us to find correlations between spatial structure and typological and functional traits. What I think was interesting in this little project is that it allowed us to unsettle architectural typology as an analytical category and become a more gradient understanding. You know how we think of typology as something that is a binary. Something is like a tower or I don't know, like a cloister or etc. In this case, this type of distant reading allowed us to paint a more gradient picture of different typological buildings. In another architectural distant reading, led by my student Michael Hasey, we were interested in the morphological sort of signature of a particular typology of churches in Eastern Europe, in Ukraine and Poland, that were built between the 17th and the 19th century. So using 3D reconstruction techniques, basically drawing data from the internet, from Google Maps and Google Street View, we were able to develop a very large data set of these churches and reconstruct 3D models that we then analyzed using deep learning methods. And that allowed us to kind of find particular stylistic families within that broader kind of perspective. We are continuing this project, and Federica has been contributing to the next phase of this project, where we are looking at one specific example. The second move concerns hybridity. And I want to here talk about computation, about something that is inherently hybrid. And many of you probably know that the root of the word computation is to put things together, right? Computare, right? And I think that's a very nice way of thinking about all these practices. It's about putting these similar things together and finding relations and new ways of overlapping things. I'll illustrate this with a couple of projects where we are using different disciplines and different lenses to look at urban questions. This is a project called What You See is What You Get, where we kind of, this is Pittsburgh's Market Square, which is one of the most important public squares in Pittsburgh, and we implemented a system that used computer vision and machine learning to identify patterns of movement in the space and find correlations between those patterns of movement and some kinds of commercial activity, the impact of certain furniture in the space, and so on. Part of the idea here was to develop a language to speak about how human activity is shaped by the built environment. And I find it interesting because it involved collaboration with the city of Pittsburgh and a group of commercial consortia, and ended up creating a very interesting sort of set of urban events and transformations. Another example that also looks at urban data, this is the work of one of my PhD students, Jim Marie, and Jimo developed a new data structure to qualify urban information, right? So he was interested in developing a data structure that qualified not just a city as an aggregation of individual buildings, but that qualified the neighboring spaces around buildings. He was interested in using deep learning to understand how that may help us see the quality of urban space in a new light. There's not a lot of time to go into details, but one of the results of this project is basically a method to compare different cities in terms of the quality of urban space, that instead of going from formulas, take into account the individuality of each space. So again, a gradient representation of maps that starts to kind of give us insight into what happens in terms of urban fabric, in terms of urban space, in different spaces. And finally, the design of interfaces for users to interact with data and machine learning contexts. I think this is important because it's always kind of lost in the conversation, I feel, because we're as architects, we're often users of technologies, but I think we should also think of ourselves as designers of tools and tool builders and tool makers. So a lot of the work that we do in the lab is to kind of develop new tools to engage with these technologies, new ways of visualizing data, new ways of interacting with AI systems or computational systems more broadly, and so on. And so very quickly, a couple of examples. This is a very nice exploration by Eric Humberg in the lab, and Eric is an artist. He was interested in developing a tool that allowed him to use neural networks in a more intimate way, in a more instead of just going from input to output. He wanted to create a tool that opened up the tool in order for you to kind of actually tweak the filters of the neural network. And then he thought, and I think he got really interesting results. He was interested in thinking of a neural network as a craft-based artifact. So he basically developed two tools, the kernel tuner and the network builder, that basically engineer a kind of interaction. So here is actually editing pixel by pixel almost how the neural network is recognizing certain visual patterns and so on. This is a very custom tool. This tool will make sense as a general purpose tool. This was the tool that an artist developed in order to support their own kind of artistic exploration using these tools, and I think that's profoundly interesting. The last project I'll show, it's rethinking automation in construction. This is a project that is also kind of an example of hybridity. It's a close collaboration with colleagues of mine in the Robotics Institute at Carnegie Mellon. And part of the idea is to bring robotics technologies and AI technologies to the very real and messy world of construction sites. Right? So we started using a technology that Fredy also mentioned, reinforcement learning, because we were interested in how an AI system could be responsive to the changing conditions of an environment. And reinforcement learning, that's kind of what it's about. It's about listening to an environment and feeding back input into the policy of the algorithm in order to refine the results. So we started with some very basic kind of simulations of a group of little drones that were able to kind of, instead of being pre-programmed to do certain things like bricklaying or spray coating a building, they would be working in a sort of swarm-like fashion, understanding and reacting to the presence of each other, reacting to the need to recharge and so on. And that early experiment gave us the idea that, yes, there's some promise here. We were able to show that we could probably do that. But we started moving quickly into something a little more applied, and we started working with a large construction firm, or developing construction firm in Pennsylvania. And we spent like 16 weeks in construction sites with them, talking with carpenters and plumbers and MEP installers, observing their practices, hearing them, and trying to identify scenarios for potential robotic support. As a result of that ethnographic study of construction, we co-designed with them a very a small mobile robot that was able to sort of adaptively move around the construction site, responding to very basic commands using a simple kind of handheld interface to bring tools and materials to specific things. Part of the value of this project was to kind of think from the site up and from the building practices up, rather than from the lab down, right? Instead of, oh, we're going to automate carpentry farm work. No, we're gonna work with carpenters, and we're gonna see what would work. And it was a fantastically interesting project, still in the final stages of testing, and it involved, going back to the point of hybridity, it involved loads of technical research into reinforcement learning and robotics, ethnographic work with construction workers, participatory design techniques to involve construction actors and technical researchers together in the development of a technology, and I think it also helps understand this question of interfaces. The interface is not just what's on the screen, the interface is also how we interact and how we encounter a technological system, and I think that's an important element of architectural research today. So, to end, so more than offering complete answers, I've tried to kind of hint at what I think is important in considering AI systems in the context of architecture. I think that there are a lot of powerful creative possibilities in this world. I think those creative possibilities can be made richer if we incorporate the critical elements and the critical sort of angles that matter in this question. And I think in combination with those critical elements, I think these three concepts can be useful when we approach AI technologies in the context of design. I hope to have suggested that these are not intelligent in themselves, but also their resources, their things we make, their materials we manipulate, and they are kind of loaded with intent and reflection. So I'll be happy to engage in conversation with you. Thank you. Should I use the chat?
Yes. Okay, so thank you to our guests, and now we open the discussion moment. So if anyone have questions, I will.
Should we stay here or
everything, so we don't fall asleep.
Yeah.
Okay, so is there the microphone somewhere? Oh, yeah, maybe.
Yeah.
Here we go. So what we can do before everyone escape to go to the afternoon classes is we give you the microphone and collect maybe 2-3 questions, and then we let the guest answer. Okay? So.
It was an awesome presentation by both of you. My question is related to the application in field. It is directed towards human survey. So, artificial intelligence works with neural networks, as we saw in the professor's presentation as well, and language models. So, we saw in your presentation that MVRDV is working on a cloud that is generated by the database of your own projects. So, what at the grassroots level, what is the prompt engineering that goes into getting the output from artificial intelligence? So, what is the methodology you're adopting in order to make AI adapt towards your design language? That's my question.
I have a more general question for during your lecture, you kept on mentioning this word creativity. This is creative, this is creative, this makes this more creative. Very simple question. How do you define creativity? Because for me, creativity is not something definable. Maybe you can define it by a certain society, maybe you can define it by certain groups of colleagues, but your product is targeting a huge crowd. So,
Last question for the first round.
I have a quick question for Professor Dan. You were talking about that you collected some data from the laborers for the construction site. If you can tell us a bit more about this methodology about the laborers, because there's also the laborers who will be using a building after this construction. So what about that point of view? It's a very interesting example we can have is the logistics. Where the laborers are quite doing the same movement, so what about after that level of the okay.
Okay, so to answer the first question about how we go about training our own models or LoRa's, the important thing is that it's still a very open field, so we're still learning, and that's why I mentioned that we train 10 generations of the model, and then from those 10 generations that we trained, we take the best one, the one that's generated the results that we'd like to, that we see that are approaching most results that we train on. Of course, we also, so first the process starts with getting the image, getting the pair of the images, And that's generated automatically by the AI system. So AI system, you simply plug in the image and it will create an automatic caption. Then we have to, so the process then becomes a bit more refining these captions, because the captions are very generic. And you can caption it with different methods. So there's 3 or 4 methods of captioning. Some captionings are describe better some images that are made, some architectural images, some other captioning methods are more trained for generating images of people or persons. So we really have to investigate all those different approaches or different captioning methods. And then the important part is really, so if we're, for example, training the collage neural, we describe what we want the model to include. So, for example, we describe the type of elements. So we use certain thing called trigger words. The trigger, when we type a certain trigger word like collage style, it will recognize it once the LoRa is trained and then apply that style. So in the way it's really a learning curve also, the training part. So, but we do have all these epochs or generations, and that's why we also get to some points where we get overfitting, and then the model is too trained in a way, and you get results that are messy.
Actually, my question is more oriented towards the learning part of it rather than generating part of it. How do you optimize or so artificial intelligence is a tool that everybody can use, but for the design to be MVRDV specific, what is it that you follow for your cloud to learn from your previous design, so that it has that MVRDV character to your design, and it's not any generic product of any design tool?
No, but I think the important thing is that the cloud is simply to classify the images. Then once the images are classified, we take, so what basically makes it MVRDV is that we're training it on MVRDV images. So, and we classify it by images that have the same style. So we took all the images from the catalog, they're all axonometrics, and we filter it to be axonometric images. So it will learn how to do an axonometric image. So the captioning is important, but also the data, the initial images are the most important part of taking the axonometric view, and the lower out will make axonometric views. And then the question of what is creativity, that's a very great question, because it's also like going to the semantics of what creativity really is. But I think creativity is a reimagining a combination of different concepts, and that's the interesting different concepts, but also following a specific prompt. So the creativity first comes from the pilot, the human, where it gives it instructions in the form of prompt. And once you have those instructions, then you use the creativity strength. It's how close it will follow your specific thing. So if you give it too much of denoising strength, then it will really try to generate exactly the prompt that you generated, but it won't generate a nice image. But at the same time, because you have this slider, you can really play with combining. So basically, the way it's trained, every word is a vector, and that's where the magic comes in with the special prompting. That's why we start seeing these new roles called prompt engineers, where you really start to modify certain vectors or words, and that's what I was showing a bit of adding more weight to certain words. So what these diffusion models, what they do is combine different concepts. So each word is a completely different concept. And that's where the creativity, I think, lies, where unfortunately we are now seeing that we as architects want to be the ones that are behind the wheel creating. that what these tools are doing is they're creating new images with you more in the back seat and having these possibilities of combining the two concepts, right? So as you see, for example, the LoRa's, you have a gradient of how much you apply. So that's the creativity that I'm discussing. Finding that gradient that you decide is a good amount of input.
Thank you for the question. About the ethnographic elements in the project. To give a little more context, there's a field of kind of research and practice called kind of science and technology studies and computer supported cooperative work that has been very influential to how we think about technology design. And part of what that practice-based approach means is that instead of well, it's about trying to kind of involve in the design process directly a richer and more direct understanding of the contexts of practice that those technologies are meant to support, if that makes sense, right? So instead of trying to have like a focus, like a design team in a lab or in industry kind of context, designing a technology for a user that is removed, it's about trying to kind of get as close as possible to the actual practices and concerns that as well. That has been influential. That's been almost like a methodological premise of that project. We focused on construction workers because we were interested in shifting the conversation a little bit in construction automation. If you're familiar with that field, a lot of construction automation literature is drawing from manufacturing contexts where the premise is that there's like a robot arm that is kind of doing sort of replicating the work of a builder or something like that. And we were interested in thinking of construction sites as what they are, not as what they are in a theoretical way in a lab, but construction sites as they happen in the real world, which is a lot of people, you have different materials on the floor, you have different trades, different kinds of expertise, and so on. So what kind of robotic support could be adapted to that kind of context? And at the same time, we were interested in working with a real understanding of that space, and that's why we chose this kind of ethnographic-based design ethnography approach to construction. We don't call it construction automation, but robotically assisted construction. And I think that's kind of what is at the core of that project. The difference between manufacturing contexts and construction hasn't really been addressed successfully, I think, in contemporary research. The other part of your question, I think, had to do with what about what happens next, right? Like after construction, right? And yeah, that's not something this project considers. This project is particularly concerned with. Yeah, actually, it's very narrow. It's carpentry, formwork installation, very particular stage of construction, and so on. And how to build a system that assists that work, the cooperative work of people doing that work. But there's a lot of interesting work in the building automation space about sensing environments, capturing data to kind of optimize thermal efficiency and so on. And I'll be happy to chat more, maybe give you some references on that. I think that's useful.
Thank you. Are there other questions? Want to raise your hand if you have questions when we pass the microphone.
Hi, my question is to Professor Fortich. I think it's a bit related to the creativity question. My question concerns the copyright topic. That you mentioned that you in MVRDV use the studio's library to create new prompts and new images, and to actually avoid this problem with copyright. But doesn't this creates kind of a limiting effect. It seems to me that long term it becomes all the same type of drawings, and it limits the creativity of the studio to create new things. And how can we avoid to maybe go outside this box and don't deal with the copyright effect in the other thing?
I have two questions. First question I wanted to ask if we want to apply as an intern for MVRDV. What qualifications should we have, especially for the AI product? And another question from you. I wanted to know, because there is always this danger of being so much dependent or trustful to AI. How do we work? Do we investigate all this AI thing?
Yeah, hi. It's a very tough presentation, but both were interesting. I have a question related to the last presentation actually, but it's very open question, so it's to both of you. And it's related to the sustainability. My question is, what's next? I mean, you mentioned the impact, the negative impact of using, and I will say even in architecture could be a threat if you consider the material, or I don't know, very crazy or creative ones could be more expensive in terms of material. So do you see this as a threat, like something that we cannot solve for now, or do you see the AI a tool that can help somehow also on this part of the work?
And I wanted also to connect to your first question about what's the call for MVRDV to make it more general, because actually my question was what are the competencies that are required to manage these tools? So the architect can just write the prompt and have images, or there are deeper knowledges that are needed, there are different possible layers. So what are the competencies of the new architect? Maybe this question can be open for both of you. Maybe Daniel, you can answer first.
Okay. So thank you for the questions. I can't remember more. So let's start with the last one. I think the kind of work that I showed shows you that I believe deeply in building strong technical literacies in architecture. I think there's something that Sherry Turkle, who's like a social scientist, has mentioned in relation to this new kind of the implementation of these technologies, and is that to be a citizen in a world shaped by these technologies means that we need to have a basic set of literacies in order to understand how they are constructed. And when she wrote this, she was referring to simulations and things, very simpler things. But I think this touches on the question, the other question as well. But I think if we stop thinking of ourselves as mere users and recipients of these technologies, and we start to understand a little better how they are structured, the kind of data that goes into them, the kind of algorithmic processes that go into them, if we learn about their longer histories, we will be better equipped to confront those fears and to kind of be more creative and also more to have a better time using these technologies. Another way I think about that question is to try to think of ourselves not so much again as in the receiving end of those technologies, but try to remember that we are building them as well. Like we can and should be designing the kind of interactions that we want to see in design architectural contexts with architecture with artificial intelligence methods. I think that's important. And I'll let you go on that.
Yeah, I think regarding this question about what competencies are important to you to have right now, I think it has a lot to do with what I mentioned critical thinkers. So now we're going to get a lot of information, even more. You can generate ideas really quickly or images really quickly. You have to be a critical thinker and ask yourself if this is a good idea or not. So I was just reading an article or a story that just recently ChatGPT is able to generate information and documents that are sometimes better than it's created by human lawyers, for example. And so maybe a lot of human lawyers could be replaced, but not the critical ones, not the ones that are looking at the information and saying, hey, maybe we should look into this research. So this I think is the most important of the part of the competency, but also we start becoming a little bit more like debuggers. So now we don't have to write our own code anymore because of ChatGPT also being able to do that. But you do have to figure out ways of how to debug problems, because always something comes up, an error comes up with when using all these AI tools, especially now that they're so new, no one really knows how to use it. So you have to be happy to figure out a way to solve it and look online. So it's more this flexibility of debugging, I guess. Regarding the creativity question, again, I think what is creativity? Creativity is the experience of, so you have a certain experience in designing, and that experience allows you to combine various concepts, right? So what Stable Diffusion allows you, or these diffusion models allow you to do is, in gross terms, you have an image of a sketch and you have an image of an Eiffel Tower, of the Eiffel Tower, right? So what and this is a copyright image of the sketch, and this other one is the copyright image of the Eiffel Tower. But what it allows you to do is mix these two concepts and find an image that's in between. So is that copyright or not? So it opens up a very big question on what is really copyright or not. Is something that's remixed copyright? And you were mentioning the limiting of creativity because we only train on MVRDV models, but all these models don't function independently. They need, the LoRa's are very, very small models that are half the size of the big artificial neural network, the Stable Diffusion model. So it's already building on top. Stable Diffusion already knows how to do the Eiffel Tower, this example. So what we can do is teach it the MVRDV style collage of making the Eiffel Tower. So there is, of course, there's still this copyright question that I think everyone is trying to figure out, because even the creators of Stable Diffusion are facing 2 lawsuits, one from artists and one from, I think it's Getty Images that are constantly getting. So it is an open question still. I can't answer it.
One thing I realized that another element of the question was the sustainability element. And I think that's a really important one. I don't have a good answer, except to say that I think I am really interested in implementations of machine learning and a quote-unquote AI that rely on very small datasets. Datasets that are interactively generated with users in the process of making something. I didn't show some projects that we've done in that space, but I think that's a nice it's a potential avenue that goes a little bit against the grain of big data sets and this idea that the more data, the better. But the idea that a user can interactively generate a small data set in order to achieve a particular effect or purpose. I think that's interesting. It's like the Fiat, the small Fiat versus the monster truck, right? It's the smaller, more tailored tools that do not necessarily rely on large computational kind of resources. I think that's a good potential avenue for people.
And maybe also to talk about the sustainability aspect. generating an image. I think the problem is not generating the images, I would say, because you will have energy consumption. I think the problem is more going down to the roots of making energy more expensive to change the system, because when something is expensive, when water is cheap, you will just use it with, well, in general, people, the society uses it more than if you make it. So I think it's more changing the system, making energy be more costly, so that, but of course, there's still very controversial subject of how to generate images in a more that doesn't require so much energy. But I think that also finally that I saw that you mentioned in your lecture that generating an image is as much as it said that it's as much as charging your phone. And I think I would be critical of that, because in reality it takes like 20 seconds to generate an image. But of course, there's still this use of energy. But the biggest issue is more when you're training. So that is the training part is what takes the most amount of energy, more from my perspective, more than generating images. It's the training to be able to generate those images.
Yeah, and I think it also refers to the server side. You need to pull servers, so it's an aggregate.
Thank you. We have still time for one round of questions. I wanted also to remember you that we will continue also the discussion tomorrow morning then at 10 at the Valentino Castle al Salone d'Onore, because tomorrow is the program of Biennale Tecnologia that probably all of you know, and you have seen all the posters all around Politecnico di Torino. Tomorrow is the day of focus architectura, and there are a lot of events related to architecture with guests. And one of the first one is at 10, a discussion again with this guest about artificial intelligence in architecture. So last round of questions.
Okay, again, based on the previous question, like maybe what I'm trying to address, in other words, that I can understand that we are trying to use AI in a good way. Let's say I'm trying to use this in a good way where we can feel less alienated with our relationship with architecture as architects. So we have this huge gap of our relationship, our direct relationship towards architecture, and I can understand that we're trying to narrow this gap, but at the same, because of capitalism, how it's distorted our relationship of the human with the nature. So, and the gap is just keep going. And maybe it's a naive question that how do you think we can keep the hope? Because at the same time, you were talking about the environmental part. Maybe my question has two points. How to keep the hope? Because to face this environmental impact, because in the end you are also using the AI and so how can you weight your priorities as an architect? And
Right. Yeah. My brain is processing the question.
I have a question also related to sustainability, considering the other part of it, also related to energy, but I see that AI is used to generate designs and create images of these designs, but I never saw it considering the side effects, for example, overheating. So I don't know if it's being done or not, if I've never seen it done yet, but is it being used to create like passive and passive heating cooling strategies and like avoid the side effects of our designs and find solutions that are simple, based on full calculation that are being
Just one last question. Modera, I wanted to ask, on the basis on what you told us today, if you were a young architect or a student, which kind of competencies and which would be
Okay, well, yeah, I have a response regarding that. I think there's two ways of looking at it: the technical optimism or technical pessimism. Of course, we don't have the questions for everything regarding the sustainability aspect, but there are approaches to saving energy. For example, the state diffusion runs locally, so it runs on our own computers, and if we know Nature and other software being run on external servers, and we don't know how the servers are being powered. But if we know where our energy is coming from locally, then at least we can choose sustainable energy source. And secondly, also there's the question of how we will solve this problem, and story comes up from just recently Sam Altman, which is the director of OpenAI. He came up with a straight face with the shareholders of the people that are investing in OpenAI. Said, we don't know how we're going to make money, but if we develop an AGI, the AGI will know how to make it. So there's always the technical optimism and technical pessimism. I like to stand with that. But this is the mining aspect. I can also see it as looking at it from the sustainable. If you ask the right questions, you get the right results, right? So that's how I see it.
For those questions, that's the question that keeps me up at night. It's the one I think how we engage this technology in a way that shows an awareness of the world is important for us, I think. Donna Howard, whom I cited in the presentation, she's a scholar. She writes, she wrote a really nice book recently, a few years ago, called Staying in Trouble. I mentioned in the presentation. And I cited her because she talks about how important it is to not try to simplify away the questions. There are difficult questions that you cannot look away. And she also says something that I think applies to your question, which is technical people. They are not the problem. We need to work with technologies. We need to think about how to reasonably, critically, and humanely work with them. The tough questions about the environment, about justice, and so on, need to incorporate elements of technical expertise. Perhaps not in the way that they are implemented now. And I think that's important. I also want to recognize that the work that I showed today is also a work developed in a very kind of privileged space. It's a laboratory in a university that has resources and is connected to human and material resources that allow us to experiment and do things that would be difficult to make in another context. The whole driving some of those projects that I think you correctly pointed out, they're trying to challenge some of the driving logics of surveillance and exploitation and violence that underlie a lot of these generative technologies. I'm trying to show a different possibility. On a good day, I'm optimistic, but I think it's also, I think it's a struggle and it's easy. I wanted to also say something about the question about environmental and sustainable elements in these technologies, because I think the work that I was showing, and I believe this also applies to both for presentations. It's not exactly dealing with questions of thermal efficiency or environmental sustainability directly. There are researchers who are employing similar technologies to harness data to kind of make cooling more energy efficient, right? And I think that's a very good, very important part for field. People thinking about building diagnostics and performance and thermal efficiency and using these technologies in that context. And I think there's promise there. I also feel, looking at it from the inside of these research worlds, I also think that because there's such a large prominence of machine learning as a method, it's almost as if anything has to do with, anything has to be done through this very narrow vocabulary of methods and techniques. And I think that sometimes in the research world generates this kind of like a gold rush, like everyone is doing the same thing, and sometimes I feel some other alternatives are being overlooked. Maybe we don't need that much data to, give us some knowledge that we have acquired over millennia of building that doesn't require us to put sensors and cameras everywhere. Because sometimes behind those infrastructures, there's other projects behind, right? And sometimes things that are purported to be about efficiency are also engender other possibilities that are less savory, right? But so let's stay with the trouble, and I also think it's important to remain open to the possibilities of enchantment with this system. I think we need to demystify them, but also find opportunities for enchantment and for creative engagement.
So thank you very much for the presentation, for answering our questions. And I want to also remind you that all the events of tomorrow are both in Italian and in English. So that if the presenters the guests are English language speakers, there will be an instant translation, and the opposite if the presenter is an Italian speaker. So everyone can attend every event of tomorrow. And thank you for all of you that stayed with us in the room, even if you have so many things to do on Thursday, because we have lectures in the morning and in the afternoon, so everything is so quickly. Thank you.
Thank you.
Thank you. Thank you very much.